Hello, science fans. Today we're diving into the world of systems analysis. Consider this before you build anything: a rocket ship, a robot, a really cool piece of software. You need a plan. You need to know exactly what it's supposed to do. That, my friends, is where requirements discovery comes in. It's the process of figuring out what a new system needs to accomplish. Think of yourself as a detective. You're on a mission to uncover all the clues, all the needs, all the expectations from the people who will use the system. This isn't just a suggestion, it's the most critical first step in any project. So, what exactly are these requirements we're talking about? A system requirement is a feature or a characteristic that the system must have to meet its purpose and be successful. It's a rule the system has to follow. We can split these rules into two big categories. First, we have functional requirements. These are the things the system must do. For example, a functional requirement for a library website might be: the system must allow a user to search for a book by title author. It's an action, a task, a function. It's the what of the system. Then we have the other category, non-functional requirements. These don't describe what the system does, but how it does it. They are the qualities or constraints of the system. Think of them as the personality traits of your new creation. For that same library website, a non-functional requirement might be: the search results must appear on the screen in less than 2 seconds. Another one could be: the system must be secure enough to protect user data. Performance, reliability, security, usability. They are the how well of the system. Now, why is all this so important? Imagine building a car, but you forgot to ask how many seats it needed. You might build a fantastic 2-seater sports car, but the customer was a family of 6. They can't use it. That's a project failure. Missing or incorrect requirements are the #1 reason why technology projects run into trouble. They lead to wasted time, blown budget systems that nobody wants to use. Getting the requirements right from the very beginning is like laying a solid foundation for a skyscraper. Without it, everything you build on top is at risk of crumbling. Not all requirements are created equal. To build a great system, you need great requirements. So, what makes a requirement good? Well, scientists and engineers have come up with a checklist of characteristics. A good requirement must be accurate. It has to be a correct statement of a stakeholder's need. If the user wants a blue button, the requirement shouldn't say they want a red one. It's about getting the facts straight. This sounds simple, but it's easy to misinterpret what someone says. A requirement also needs to be consistent. This means it doesn't conflict with other requirements. The system must be accessible to everyone, including users with visual impairments. All on-screen text must be in a tiny 6-point font. Those two rules are fighting each other. Requirements must live together peacefully. They must work in harmony to create a cohesive, functional whole. The requirements discovery process isn't a single event. It's a journey with several key stages. Think of it as a scientific investigation. The first step is problem analysis. Before you can propose a solution, you have to understand the problem inside and out. What's not working right now? What are the pain points for the users? What is the root cause of the issue? Put on your detective hat and really dig deep. You're not looking for system features yet. Become an expert on the problem itself. One of the most powerful tools is the Ishikawa diagram, also known as a fishbone diagram. Why? Because it looks like the skeleton of a fish. It was invented by Kaoru Ishikawa, a Japanese quality control expert, to help teams brainstorm the root causes of a problem. It's a visual way to organize your thoughts and make sure you're not just treating the symptoms of a problem, but finding the actual cause. It's brilliantly simple and incredibly effective. Here's how it works. You start by writing the problem statement at the head of the fish. For example, the problem might be guests are unhappy with hotel check-in process. Then you draw a long horizontal line, the spine of the fish. Off of this spine, you draw several diagonal lines, which are the bones. Each of these major bones represents a general category of potential causes. For a service process like hotel check-in, common categories might be people, process, technology, environment. These categories help you structure your brainstorming. Now the fun begins. For each category, you and your team brainstorm specific potential causes that fit into it. Under the people bone, you might list causes like front desk staff not trained properly, Staff are overworked during peak hours. Under the technology bone, you could add, computer system is slow, credit card machine frequently fails. You keep asking why, to drill down deeper and deeper, adding smaller bones off the main ones. This creates a detailed map of all the possible reasons for the problem. The real beauty of the fishbone diagram is that it turns a complex problem into a clear, visual map. It encourages a team to think about all possible causes, not just the most obvious ones. It helps you see the relationships between different factors. System analysts have a whole toolkit of fact-finding techniques. Let's look at 7 of them. First up is interviews. This is where you sit down and talk to people one-on-one or in a small group. It's great for getting rich, detailed information and for building a good relationship with users. The downside? Interviews can be time-consuming, and sometimes what people say they do isn't what they actually do. Still, it's one of the most popular and effective methods out there. A second technique is questionnaires or surveys. You can send these out to a large number of people to gather a lot of information quickly and cheaply. They're great for getting quantitative data like, on a scale of 1 to 5, how satisfied are you with the current system? The weakness is that you can't ask follow-up questions easily, and it's hard to get detailed, nuanced answers. Third, we have observation. This is where you, the analyst, watch people as they do their jobs. It's a fantastic way to see how things really work, not just how people say they work. Fourth is document analysis. This involves studying existing documents, forms, reports, and system manuals. This can give you a great understanding of the current business rules, data, and processes. Fifth is prototyping, where you build a small-scale model or mock-up of the new system. This lets users see and interact with your ideas, providing very specific feedback. Sixth is researching vendor solutions, where you look at existing software packages to see if one can solve the problem. And seventh is joint requirements planning, or JRP, an intensive workshop to get everyone on the same page. When you're conducting interviews or participating in workshops, one of your most important skills is listening. Now, I don't just mean letting sound waves enter your ears, I mean active listening. It's the difference between hearing a noise and understanding a message. Active listening means you are fully concentrated on what is being said. You understand it, you respond to it, you remember it. It's a conscious effort. When you're an active listener, you're not just waiting for your turn to talk. You're trying to see the world from the speaker's point of view. First, pay attention. Put away your phone, close your laptop. Make eye contact with the speaker. Show them you're engaged. Communication is so much more than just words. As a systems analyst trying to understand people, you need to pay attention to this silent language. This includes body language, which is the way we communicate using our bodies. Posture gestures, facial expressions. Different cultures have different norms for personal space, but generally we have zones. Intimate zone, close friends and family personal zone, one-on-one conversation social zone, small group interactions public zone, speaking to a large audience. A JRP is an intensive, highly structured workshop for a concentrated period, maybe a few hours or even a few days, to work together on defining the requirements for a system. So, how do you put all this together into a smart, efficient strategy? Here's a simple, step-by-step approach. First, start with document analysis and research. This strategy, from broad research to focused interviews to collaborative workshops, ensures you gather complete, accurate, and verified requirements. It's a scientific method for building systems that truly solve problems. And that, my friends, is what it's all about.